Hi guys, this is Austin, and welcome to my everything there is to know about a 3800 engine in a Fiero. This is the second upload of this video. I decided to re-narrate it because the first video I misspoke quite a few times and didn't explain things very well. Additionally, in this video I'm going to discuss all of the modifications I chose to do to my engine and explain why I did them. In general, there are four things that make combustion. That's fuel, oxygen, compression, and ignition or spark. You can increase power generally by adding more fuel and oxygen proportionally, or by mixing fuel and oxygen together better, or by increasing compression. Also by igniting the fuel at peak compression, or perhaps changing the fuel octane rating by switching fuels. So let's discuss ways to get better airflow into your engine first. Upgrading the camshaft will be your most significant source of increased power. This allows your valves to open further, allowing more air into the engine, as well as changing timing around to optimize your engine for performance instead of for a factory balance of performance, fuel economy, and emissions. Instead of changing a camshaft, some people opt for a higher ratio rocker arm, which allows your valves to open further, allowing more air into the engine instead. This is a very cheap alternative. Additionally, you can use a supercharger or a turbocharger to force induction on your engine, meaning you can force more air into your engine by compressing it first. Next comes porting your cylinder heads for better airflow through the cylinder heads and adding a larger exhaust and a larger throttle body so more air can move through the engine. Moving on to fuel. In order to increase fuel flow to support a constant ratio of fuel to air mixture, the computer must adjust fuel flow with a pulse width modulated or PWM control. Fuel demand is determined by mass airflow or MAF, intake air temp or IAT, manifold air pressure or MAP, and oxygen or O2 sensors. If the fuel demand is about 15% higher than the factory programmed fueling, then the 3800 computer cannot add more fueling and needs to be reprogrammed. In order to support more fuel flow, you can regulate your fuel pressure higher on stock injectors or go to larger injectors. Higher fuel flow may also require a higher flow fuel pump. Also, to support E85, the fuel to air ratio mixture must be reprogrammed on this engine, while modern cars can typically adjust that on the fly. Changing fuels can increase power because different fuel itself can have higher octane readings, meaning it can withstand knock. In America, octane 87 through 93 are common. E85 itself is even better, as it has an octane rating of 105, and it itself cools combustion down because of the additional heat energy it consumes in order to transfer from liquid to gas. Typically, a wideband O2 sensor is needed to tune any kind of fuel setup properly, but it can be done without one. Moving on to ignition, there is limited power gains from this. You can advance or retard spark timing in programming in order to try to spark during peak compression, at which most power will be made. Gapping spark plugs correctly can be vital for functionality but won't add much power. Lastly, compression can be increased for more power. However, this engine limits the ways you can do that. The primary way would be to change the shape of your pistons, followed by changing the head gasket out for a thinner one. Except this can significantly increase heat going through your engine and can cause clearance issues. The first limitation to adding power is heat. Overheating can cause piston rings to close, pre-ignition or detonation, known as knock. Pre-ignition is caused when the combustion chamber is too hot for the fuel being used, causing it to ignite prematurely before the spark, and detonation is an uncontrolled ignition after the spark. This causes wear on bearing and rods. Oil can burn also, which causes more friction and wear. Also, the components of an engine can be deformed, causing many more problems. Engine components are also limited by a power rating. A bare 3800 block is estimated to be good between 400 to 600 horsepower on stock crank and rod setups. There are many ways to fight heat. The first would be intercooling, which cools down the air after it has been compressed. You can add lower temperature spark plugs, which can wick away heat faster to decrease the likelihood of detonation and pre-ignition. You can also add a lower temperature 180-degree thermostat and change the cooling fan set points in the computer for your coolant. But beware of this method because it will not heat up the oil to optimal lubricating temperatures. Additionally, some inject methanol into the intake to continue to cool combustion. And this, as you guys know, is a E10 Gen 5 blower that came on a 3800 Series 3. The Gen 5 blower draws 13% less power from the crankshaft. It decreases the operating temperature 15%, and the volumetric efficiency is 9% greater than a Generation 3, meaning 9% more power. This is the boost bypass valve, which can open up and allow air to come in directly from the intake and go to the intake manifold without going through the supercharger first. It opens up with a combination of a very high manifold pressure and a very low vacuum. It can also be switched on by the computer. Now, of course, a Generation 5 blower comes with its own type of air intake manifold, so make sure if you get the blower, you get the air intake as well. This is the PCV valve, or positive crankcase ventilation valve. It removes the crankcase fumes from gases blowing by piston rings, or blow-by, during combustion, and it relieves the crankcase pressure, preventing that pressure from forcing oil to leak through seals. Air is drawn from the engine intake vacuum inside the supercharger through a check valve that is under that cover. The air is drawn directly from the crankcase through a hole in the intake manifold. Fresh air enters the crankcase through a similar hole that comes from a port in the throttle body. A lot of people try to run catch cans. I wouldn't do that on this setup because I have to completely bypass this PCV. I'd have to put a catch can between here and the intake somehow, and that is just too much work and piping to worry about. Other people vent to atmosphere, but I would not do that as well. Meaning you put a little filter here to draw air in when there's a low pressure inside the crankcase. Don't do that because what that'll do is it'll suck air into the engine, which is not metered, and then that air will eventually return into the intake through the PCV anyways. This is a North Star throttle with a cable-driven throttle. It is 75 millimeters, just like the Gen 5 supercharger. Now the Gen 3 supercharger is actually, it's like 68 or something millimeters. Now you can keep the stock Series 3 throttle body and put it on your Series 5, but you've got to get a throttle plate adapter anyway. This is an adapter from a Gen 5 supercharger to a North Star throttle body. It gets rid of the coolant passage that used to heat up the throttle body. Another fun tidbit is this guy right here. This is actually just external coolant passage. Literally coolant comes out and goes back in. Don't take it off because then you've got to replace a gasket. One commonly failed part internally to superchargers is a plastic coupler. You can tell if it's worn out by a rattling noise it might make. This here is a vacuum port that helps operate the boost control solenoid. This will go to my brake booster on the Fiero, and this guy will go to the old vacuum cruise control on the Fiero. Otherwise, if you're using the new cruise control from the GTP, you can just plug that. So let's talk about blower pulleys. I have a 3.4 inch pulley and a 2.8 inch pulley over the, this is the factory one here, this is 3.8 inches itself. So the smaller the pulley, the faster the blower will spin. The faster the blower spins, the more air it moves. Also, the faster the blower spins, the hotter the air will be. So you've got to take extra precaution to cool down your combustion. You might want to do that with an intercooler sandwiched between here that literally filters or funnels cooled or coolant and cools the air down as it enters the engine. So these are AR103 spark plugs. They're auto lights. The R is for racing. They have an electrode that's cut a little bit back. It's supposed to be better spark. And the 103 is the temperature. I believe the stock are 606s, which are 3 ranges warmer. So this is from Intense. I talked to them on the phone quite a bit. They say that you don't really make much more power below a 2.8 inch pulley. And if you get below a 2.8 inch diameter pulley, you have to trim the snout down of the supercharger. I don't really want to do that. You can get a special tool to do it, but it kind of weakens the casting, and I just don't want to do that. I don't have any need to run that much more boost, partially because I'm not cooling my combustion down as much as I possibly could be. One thing to possibly worry about is when you go that small on a pulley, your belt might start slipping. So some people go to actually 8 ribs. These have 6 ribs on them themselves. So then you'd have to change your balancer's ribs too. Now you need to get a pulley puller to install these guys. This is the 2.8-inch pulley versus a 3-inch pulley. So as you see, that's a lot smaller. It'll spin a lot faster. Now the pullers, they say to get a special one designed specifically for this so that you don't damage the snout or bearings or anything in the supercharger. You can buy some interchangeable ones so you don't have to press them on. Instead you press a hub on and then you can bolt a new pulley on or off. So you have 2 different size pulleys here. I got mine both from a shop listed in the build thread. Knock sensors detect knock. This here hose is the manifold air pressure hose, and that actually controls the boost solenoid as well as my manifold air pressure sensor, which is not actually hooked up yet. I can mount that anywhere I please. Manifold air pressure sensor lets me know how much boost I'm running, and it's actually factored into fueling calculations. I've also got 1.65 rocker arm ratio rockers from the last video. Those are slightly higher than the stock ratio of 1.6. That means that my valves open and close a little further because they're being multiplied more by that factor. Now this coolant hose setup needs to be either tapped into with a 3/4 inch NPT tap, or you need to build a bracket to retain it, because your water pump's going to put that coolant passage under pressure, about 15 psi, and it'll slowly work this guy out, and it'll pop out, and then you're going to be leaking coolant everywhere. This oil pressure sensor here is from a 1988 Pontiac Fiero. And this coolant temperature sensor is a 3-pin. It comes from a GTP, I believe. So if you have a GTP engine, you'll be fine. But it has 3 pins. The 2 pins go to the PCM, and 1 pin actually is the output, and that goes directly to your temp gauge on the dash. We sealed the coolant passages from the throttle body, so that it's not warming up the throttle body. That's really bad for power though. The hotter the air, the more knock you'll have and the less power you'll be able to run through your engine. Here is the throttle position sensor, and here is the idle air control valve. And my MAF, I have a LQ4 MAF. It's over here actually. That will determine the mass airflow going into the engine. I do want to run air conditioning. Some people don't. If you don't, you can just take the compressor off, because it is a big parasite on an engine. You probably lose, I don't know, a couple horsepower, maybe up to 5 horsepower, just by having that present in the belt system. Rotating mass itself takes a lot of power out of an engine. Also, I deleted my balance shaft. You can see that in an earlier video. The reason for that is that the balance shaft in there compensates for the fact that a V6, just the orientation of it is naturally unbalanced. There's no way to balance it because of its asymmetry. You can read about that all you want, but the balance shaft itself is statically balanced. So it's only balanced for a certain RPM range, which happens to be down low. It's balanced for smooth idling. Now when the rotating mass inside of that balance shaft spins up, especially above, I don't know, 7,000 RPM, which is around where this engine will max out, that balance shaft actually acts as a counterweight, and it no longer is balanced, and it is acting, I think the numbers are, according to Intense, over 130 pound counterweight, whipping around at 7,000 RPMs. That's not good. That's not good for balance, and that's not good for power. So you want to take that out if you're going to be revving your engine really high. Now you can see in a previous video I replaced the timing chain for double roller timing chain. The reason why you want to do that is if you change your valve springs, which I have, for much heavier valve springs. Now the stock valve spring pressure is like 90 at 50 thousandths or whatever stock is. These are 130 pound valve springs. The reason why you want to do that is, again, if you're revving higher, You don't want valve float, meaning that the valve train stops functioning correctly, opening and closing, letting air in and out through the engine. The first phenomenon is bounce, where the valve bounces out of the seat, and the second is loft, where the lifter no longer makes contact with the camshaft. Actually, if you just leave a single timing chain in there and you put a heavier valve springs in there, you'll snap the timing chain, because that's a lot more pressure on the camshaft, which the timing chain drives. There's a ton of hysteria about rebuilding the bottom end of the engine, meaning the crank and the crank bearings and the piston rods, and taking the pistons out. Supposedly, a lot of people don't have very good luck doing that, and you're better off just leaving the stock ones in there. That's why I left it in there. I just had to be really careful about when I was machining stuff and screwing stuff together that I didn't get any metal or metal shavings down in the lifter valley and down in the crankcase. I don't want any extra crap in there. Now that also made it really hard to change cam bearings. I have a friend who properly did all this. He ground the crank down to back round, and he selected the proper size bearings in accordance with his new crank size, and he's had no problem. His car's run for 5 years. So the reason why you want a GTP mostly is because this oil pan comes off of a GTP. It's a steel oil pan. It's also on Regals. And also the oil pickup is different. So when I went and I got a Bonneville the first time actually, and I got an aluminum oil pan with it, and its gasket was different, and so was the oil pickup tube. So I had to go and buy another gasket, and I had to cut it so the oil pickup tube that I had fit. I advise against that. Also, when you get a Bonneville, you get a number, or any other car besides a GTP and maybe a Regal, you get a few different brackets too that you're going to have to mix and match and put together. For example, this bracket here doesn't come on a GTP or a Bonneville at all. So I had to go to the junkyard and find one. Also, this oil filter bracket here didn't come on a Bonneville at all. So I had to go find a GTP one. The Bonneville ones was extremely hard to access the oil filter from, so I didn't want that at all. Also, because the coil pack bracket doesn't come, you don't get the pulleys, this pulley or the tensioner pulley with it, so might as well just get a GTP. And that 3-pin temperature sensor comes on a GTP and not a Bonneville. Now in later years, these compressors are actually changed. So there's several different types of brackets for them. I found that the GTP bracket, which looks like this, it comes in 2 parts, is a little bit lighter than the Bonneville bracket. And then later, Series 3 engines actually have no brackets at all. The compressor bolts directly to the block. It has the holes in the castings already to prevent certain vibrations from happening. It's Not Forgotten covers this stuff, but this, I believe, tensioner pulley is from Ford. And it fits this application great. Now I don't know about later years, but the alternator was different too, like I said before. So as you can see, I got a new torque converter, and I think if you have a GTP, since it's a somewhat lighter car, that's okay. Torque converters are actually matched to 2 things. They're matched to engine power and car weight, and it sits right there on the input shaft. Actually, fluid will come out of there and fill the torque converter up. And it's kind of hard to determine what RPM you need. That's a whole other video in itself. But when I put the Bonneville torque converter in mine, the Fiero idle at like 20 to 25 miles an hour. That's not good. So I got a higher stall torque converter. I went out of a stock, I don't remember what it was, Oldsmobile or something. And it was the same type of torque converter, a 258 millimeter one, but it stalls higher, meaning that the engine has to be turning faster in order for it to start transmitting power from the torque converter to the drivetrain. I know that out of the series it's a JXFM. JXFMs, out of the 4 different torque converters that they made for these applications, are the highest stall, so hopefully that'll be a better match for the Fiero. The main reason why you would want a different torque converter is when your RPM's creeping up, you make more power at a higher RPM in almost all cases. But your torque might drop off a little bit, but in general, the faster an engine's spinning, the more power you're making. So you want the torque converter to lock at a high RPM. because you want the engine to rev very quickly under no load so that it can rev to the peak power RPM as fast as possible. That way, more efficient, better launches, just better utilization of your power overall. So I got this fuel pressure gauge. It's the link's in the description, but that's going to sit like yay. And the purpose of that is to, well, mostly just troubleshoot, but also this is adjustable and I can adjust what pressure I want. I might be running 60 psi, and so I can easily do that with the screw on here. Now it also does have a vacuum port that will go to the manifold air pressure sensor hose as well. Now my heads are a little special. They're from a Series 3 motor. Series 3 heads actually had valves that were it was 30 thousandths larger. They're 1.83 inches in diameter, opposed to 1.8 inches in Series 2 and before. So I got me some Series 3 heads. As far as I know, that is the only difference at all. One difference that I did find in the valve covers though is valve covers and valve cover seals are a little bit different. Some of them have moldings for different corners and some don't, so pay attention to which valve seals you order. I got my heads ported, meaning that the valve openings were widened a little bit. The valves got a valve job on them. They got cut on the back for better angles to flow more air. The intake and exhaust ports were widened a little bit. They were widened to match the gasket, and the intake manifold exhaust, or the intake manifold runner ports were also widened a little bit to match both the gasket and the new heads. So that'll hopefully flow a little bit more air. Now when it comes to the head gaskets, I got the stock size thickness head gaskets. The reason is because when I rotated the crank and measured every cylinder coming out of the hole, and I measured that it was about exactly the stock distance still. So what matters is you want about 40 thousandths to get the proper quench thickness on top of the amount of distance that the cylinder comes out of the hole. So I got 65 thousandths gaskets, which is pretty much exactly stock. I wouldn't go different than that, depends on your setup, but I'd definitely measure that before you buy head gaskets. I got MLS head gaskets, they're steel, but they don't fit perfectly and aren't necessary unless I'm raising compression significantly. And of course the head bolts and everything require a certain amount of torque. Now those things combined together, the amount that you deck your heads by if you have to make them level again, the amount that you deck the surface of your block by, the amount that is out of the hole, the thickness of your head gasket, etc., and even the ratio of your rocker arms determine how long your push rods need to be. So you got to measure all those and then just measure the physical length that required for your push rods with the checker. I also got LS7 lifters. The lifters are supposedly start causing valve flow on the stock ones at a certain point. LS7 lifters, they have a little bit more of adjustment to them, but they're supposed to be a little better for higher RPM applications. EGR is exhaust gas recirculation. What that does is it's a valve that opens up under cruising speeds, and it will allow exhaust gas to come up through the exhaust and put back into your intake. That's good for a number of things, mainly just making your engine blacker than soot and dirtying everything up. The other reason for that is, again, with the emissions thing. Recirculating inert gases improve combustion efficiency and actually do cool down combustion a little bit, producing less nitrogen oxide emissions without affecting air to fuel ratio. However, the EGR doesn't actually open up under wide open throttle, so if you're accelerating, it's okay to leave on. So the bolts that yield would be the crankshaft bolts. That bolts the balancer on the crankshaft. This yields, get rid of it, get a new one. The camshaft bolt, which that's in another video. The head bolts, which I'd get rid of those anyways and get head studs that you can reuse. And the flywheel bolts, those all yield. You need to replace every one of those. All those are in the description. And that would be my oil level float sensor there. Way in here is my crank and cam position sensor. And that is just one straight wire. There's the crank And there's the cam. And this connector here, that's the coil pack bracket harness and random ground. That actually stays. That does not get changed with the built harness, at least from James Brown, it does not. I explained this in the last video, but with the E85 running, I determined that I think I'm going to be moving enough fuel that I need at least 80-pound injectors. 60s were going to barely cut it. They might have been okay though. Also, I haven't really mentioned anything about piston ring gapping. I didn't take apart my pistons, that's why I didn't gap the rings, but you probably should check the ring gaps yourself if you do get that far into it. As far as I know, making 350, 400 horsepower, the stock gaps should probably work okay. I don't know that for a fact, but I've never ever seen anything on them, and I've searched for ring gap topics before, and nobody gaps them. They just use stock parts, stock gaps, everything. Also, something not really mentioned was the crankshaft clearances. I never measured any crankshaft bearing clearances. I did wiggle them a little bit to see how much play there was, and actually bearings are all pretty tight and pretty solid. This is a low mile engine here.